Okay, folks, fifth years just wanted to run through what's happening with regards to today's work. I'm in the process of making the video of the corrections of the work that you guys done yesterday. So I'll have that up on YouTube. I'll pop a link up on Edmodo as soon as I have that finished. It's long enough, but you had 2 classes worth of time to get through the work yesterday. So I will have that up as soon as I can. Just wanted to run through what's happening with regards to an arithmetic sequence. We've talked about arithmetic sequences already, and in this case, where we can see what they do is that they go up by the same amount each time, essentially. Okay, so if we have a sequence of 2, 4, 6, 8, 10, we know that they go up in they have a constant difference, or they have a common difference, that they go up in 2 each time. So we've looked at that in detail, but the next bit that we need to look at is what this guy was kind of working on, Carl Friedrich Gauss. Okay, so these are called Gaussian's methods, or Gaussian's functions. Usually you talk about them like this. So as we said, we're looking at a sequence or a series, nice and simple, and instead of just looking for a specific number term, so you know the work that you did yesterday, we talked about finding the 50th term or finding the 101st term or whatever it might be. In this case, what we're doing is that we're trying to get the sum of all of these terms. So the idea is very simple. If we have an arithmetic sequence and we know it goes up in 3s, for example, if we've got 1, 4, 7, 10, let's say, for example, that's our sequence. What we can do with this formula is that we can figure out what the sum of all of those terms would be. Okay, so I can add up all of the terms. So you can imagine 1 plus 4 plus 7 plus 10. If I add all those values together, it gives me what? 32. 1 plus 4 is 5, and 7 is 12, and 10 is 22. Okay, so you're adding them up together. That's all that's happening with regards to this formula. The formula is very similar. We've got an n value representing the term number. We've got our a, which is the starting term, and we've got our d value, which is the common difference. Same as we did with a and d and n in the general term formula. So the letters are representing the same things. The only new one is that we've got s here, okay? So s representing sum, and it's obviously a new formula in a different shape, okay? You can see it's on page 22, your log tables. And all we got to do then is have a quick look at how these work. So you can see, find the sum of the first 100 terms of the arithmetic sequence. All right, so you can see what's happening. A is your start point, D is your common difference, and N is your how many terms you're talking about. So we just fill them into the formula. S of 100 is equal to 100 over 2, because N is 100. I've got A as my 7, which is the start point. I've got, again, n minus 1, so that's 100 minus 1, and you've got your d value, which is 3, the constant difference, because it goes up in 3s. You can see the sequence at the top right hand corner, 7 plus 10 plus 13, so the common difference is 3. Okay, so the only thing I suppose you've got to be careful with in this one is that you've got a fraction. Okay, so look, it's over 2, so most of the time you'll be able to just divide it by 2 and you'll have a regular number on the outside. And you can see there, we pop it all in, work out bit by bit, and then finally we end up with our answer. The sum of the first 100 terms in this sequence is 15,550. So you can imagine, if I go up 7 plus 10 plus 13 plus 16 plus 19 plus 22 and so on, all the way up for 100 terms, I'm going to end up with a big number, and we do have that in this case. All right, so the other examples then, just to run through them to make sure that we're clear. Find the sum of all the terms in the arithmetic series. So this has a start point and an end point, you'll notice in this one. I start at 11 and I end at 51. So what we're looking to figure out is what the n value is. We're trying to find out how many terms there are. Now, we can use our formula to do this, or we could just count them out. We could write the list out and we could count them up, but if they gave you one that went to 1,000 or 1,500, then you'd be there for a long, long time. So we use the formula to do so, okay? So we have n as the one we're looking for. We know that Tn is equal to 51 because that's the last term. So I can put that equal to 51. So I have my A value, I have my D value, and I know that the last term is 51. So if I fill those values in, you can see I end up with the general term 2n plus 9, and I want to know for what term is my last value 51. So I do Tn is equal to 51. So 2n plus 9 is equal to 51, as you've got it down here. And then you just solve for n. So small bit of algebra there. So that means that there's 21 terms. Now, we've figured out what n is, and now we can use the sum formula, which is new for us. So this is the stuff that you guys were doing yesterday. And then this is the stuff that we're hoping to do today. So we can, now that we've got our A value, our N value, our D value, we can fill them all into the formula. A was given to us 11, D was given to us 2, and N was the one that we worked out, 21, just there. So we fill those all in. Now you can see that that's an odd number in the fraction, 21 over 2, so that gives us a decimal, but we're just multiplying at the end. So hopefully most of the time, well, it should always actually, should always end up with a whole number answer. If you end up with a decimal answer, I would think that you've made a bit of a mistake. So I just wanted to run through examples of what those ones look like. You've got a couple more examples there, page 202, page 203. And what I'll ask you to try just for today, I would think that you guys should be able to do all of question 1 without any hassle whatsoever. I'll ask you to do question 3 as well. And they're very similar, but we've got negative values instead, so just to test yourselves on that. And I would hope you'd be able to do question 6 and question 7 as well. Okay, so I'm asking you to do question 1, question 3, question 6, question 7 from page 204. Thank you very much.